Alright, so in the last video of the last section, which got kind of long, I spent a lot of time showing how to come up with parameterized equations that represent a circle. Ever since the very first week in our class, we understood the standard form of the equation of a circle. And what we did in the last section is kind of learn how to go back and forth between that standard form and this parameterized form. And I even tried to make the argument that this parameterized form is kind of superior in some sense, in that it's kind of easier to recognize that you have a circle, and maybe it's less likely that you make a little mistake recognizing the center and the radius of that circle. As a reminder, over here we have to remember that the x-coordinate of the center is positive 2 and the y-coordinate is negative 1, which is a little counterintuitive, and that the radius is equal to 3. But over here we kind of see all of that immediately. There's my positive 2 and my negative 1, and there's my 3. The way I think it's easiest to read these parametric equations is to think about the x-coordinate as being centered at 2 because of this 2, but then remembering that cosine can be as big as positive 1 or as low as negative 1. So from that 2, we can kind of go up or down by 1 times this 3. So the x-coordinate is really 2 plus or minus this 3. And the exact same logic holds for the y-coordinate, which is centered at negative 1, but can get as much as 3 higher than or lower than that negative 1. If you can look at this and kind of see the 2 plus or minus 3 and the negative 1 plus or minus 3, it becomes really easy to sketch the graph, for example, of this circle. Well, in this section, we're not dealing with circles, so we won't be dealing with this set of parametric equations. What our parametric equations instead will look like are these down here. And at first glance, they kind of look like they're identical, but if you look really carefully, you might notice that while the x and y coordinates are still centered at 2 and negative 1 respectively, and the x-coordinate still gets 3 higher or lower than that 2, the y-coordinate only gets 2 higher or lower than this negative 1. So when I'm thinking about the graph, the x-coordinate is still going to be 2 plus or minus 3, but the y-coordinate is now going to be negative 1 plus or minus only 2. The x-coordinate is centered at 2, as represented by this line, but it's going to get as much as 3 higher and lower than that. So 3 higher than 2 takes me out here to 5, and 3 lower than 2 would take me over here to negative 1. And then in the y direction, I'm centered at negative 1, and I'll get as much as 2 higher or lower than that point. So 2 higher than this negative 1 brings me up here to this positive 1. And 2 lower than this negative 1 takes me down here to negative 3. The center of the shape I'm going to draw is going to be right here where these two solid lines intersect. But the dotted lines are no longer symmetric about these points. I'm not going to be sketching a circle. I instead end up with this oval shape called an ellipse. So I guess the first learning objective from this section is being able to recognize that when the coefficients on the cosine of t and sine of t in these parametric equations aren't the same number, you're not going to end up with a circle, you're instead going to end up with an ellipse. And it's easy enough to sketch that ellipse by recognizing that the constant terms in the two equations still give the center, but that the coefficients no longer give you the radius because we have these two different numbers. In order to understand what the coefficients give you, you need a little bit more vocabulary about an ellipse. But for now, sort of loosely speaking, the 3 and the 2 just tell you how far your ellipse can go in the x and y directions from the center. Before I finish this video, I want to kind of give one more example of that main learning objective, where we learn how to see how these parametric equations represent an ellipse. Maybe in this one we'll work backward. I'll start you out with the graph of an ellipse and we'll come up with the parametric equations. Doing that's as easy as just kind of reversing the steps that we did before. If you just sort of look at this, maybe you can recognize that the x-coordinate is centered at negative 4. And from that negative 4, our graph gets as much as 2 less than and 2 more than that value. So when we're writing the parametric equation for x, we could say that x would be equal to 2 times the cosine of t minus 4. Again, remember that we don't have to parameterize these things this way, but it makes it easiest to keep the cosine function with your x equation and the sine function with your y equation. Speaking of that y equation, just from looking at the graph, maybe we can recognize that the graph is centered in the y direction at positive 4, and from that positive 4, it gets as much as 3 units higher up here at 7, and 3 units lower down here at positive 1. Therefore, the parametric equation in the y direction is y equals 3 times the sine of t plus 4. From this video, really what we want to do is understand how these parametric equations represent this ellipse, and conversely how this ellipse can be represented by these two parametric equations. If you got all that, you got all you need from this video.